In this video, we're going to talk about annuities, and there's a little bit of confusion about this term annuities. There is an investment product that's sold, and I've got an explanation at the bottom of the OneNote page here to explain that. But an annuity in mathematics is this concept about how if you routinely invest money at a regular interval, it will result in some future dollar amount. We use all these same variables that we use with compound interest, the A, the P, the R, the T, and the N. And we have these formulas that are derived from the compound interest formula. So the future amount here, when the interest is compounded annually, the N is equal to 1. That's a pretty basic formula. It's basically this same formula down here, but when N becomes 1, it simplifies to this. The example I'm going to work here in a minute is going to use compounded N times per year. And then also you may want to know some present value required today of investment to reach a future amount. And here's the formula for that. And you can tell these formulas are very complicated. You're going to have to be very careful with your calculator as you enter these things in. But I'm also going to demonstrate Microsoft Excel for these. So to jump into this first problem here, we have a periodic deposit that's $80 at the end of every month. It's going to be compounded 6% monthly, and we're going to let it do that for 25 years. So we want to find the value of that annuity. So I'm going to come back up and use this formula right here. So I've substituted my values. My P was 80. My rate was 0.06. My compounding number, my N, was 12 because this was compounded monthly to the N times T, and T was 25 years. You subtract 1. Then you divide by the rate divided by N again. So let me show you how to do this on the calculator and enter this properly with all the parentheses and everything you need so you don't make any calculator mistakes. I'm going to demonstrate this with this graphing calculator, but if you have any scientific calculator, especially the one I recommended for class, the TI-30X2S, it will work the same. So we're going to put these numbers in and be careful of parentheses. So 80, parentheses, parentheses. So we're going to do parentheses twice. And we're going to do 1 plus 0.06 divided by 12. And then we're going to close that parentheses. Now here's the implied parentheses we need to be careful of. Raise it to the, and then start a new parentheses and say 12 times 25. We've talked about that error before, that if you don't put parentheses there, the order of operations of the calculator takes over and does a different calculation. Then we do minus 1, close that parentheses, and now we're going to divide and start another parentheses on the bottom for that fraction on the bottom, 0.06 divided by 12, and close that parentheses and press enter. So you get 55,439.51. The answer here that once is rounded to the nearest dollar. So this is slightly above 50 cents, 51 cents here. So we're going to round that up to 55,440. And so in that first box, you'll put 55,440. Now we need to find the interest. How much did this money earn above and beyond the initial investment? So included in this 55,440 is the $80 that we put in every month for 25 years, but also the interest. So we want to find just the interest part. So let's find out how much $80 per month, so times 12 months, times 25 years. That's the amount of money that I have invested that came out of my pocket to go into this, and let's see how much that is. So that works out to $24,000. So that's my amount of money that I put into it in this investment. I put in $24,000. At the end of 25 years, it's worth $55,440. So I made in interest the difference between those two numbers. So I'll take $55,440, and then I'm going to subtract $24,000. And that's pretty simple math. I can do that one in my head. And so we'll take that number and we get $31,440. And so that's the amount of money that I made in interest. And the interesting observation here that you all should maybe take to heart is that if you do this kind of investment, and most investments do work out this way, at the end of a long period of time, say 25 years, it doesn't even have to be 25 years, you see I've earned more in interest than I paid into it. So I did nothing really other than make an investment, and my interest was higher than my actual initial investment. So I'm going to show you how to use Microsoft Excel here, because this is the way that this calculation is done in real practice in the real world. So I'm going to show you Microsoft Excel. So Microsoft Excel has a lot of built-in functions that are really of all kinds, and there's a lot of financial ones that are helpful to us in this section here. So if you click up here in the formula bar, you see there's an FX. That will bring up a function wizard that will help you input this. And if you look under the category of financial, there's a lot of financial things that Microsoft Excel does. We're looking for the future value. So we're going to choose the FV function. And as you go through this, it'll pop up a box here, and it says, what is your rate? And you put 0.06. And now here you have to divide that by your number of times compounded. So we're going to divide that by 12. The number of periods is your time times 12. So that's how many times are you compounding. So there's going to be 300 investments here of this $80, and the amount of payment is $80. And when we press enter here, we get this number. Now, it's going to give a negative number here because it's saying if I put in a positive 80, that means there's $80 coming to me. Technically, if I'm paying $80, I should make that a negative 80, and all that would do is change that number into a positive. And so you see, just like that, by putting that in there, I get the same number, 55,439.52, which is what we got here. So I wanted to show you that little function in Excel, and because I think it will save time. And if you ever have to do this in the future, this is really the way you would do it, as opposed to using that formula.